Section 4.5, Exponential Functions and Logarithmic Equations, Part 2. Okay, so solving exponential equations, we have two methods of solving. If we can write the bases equally, then we equate their exponents. If not, then we have to isolate our exponential expression, take the log of each side, and then solve for our variable. Let's look at problem 16. Base 3, base 5 of this exponential expression. There's no way that without a lot of work, there's no way to get these to both be base 3 or both be base 5. So this method is out. Okay, so let's look at the first step and isolate our exponential expression. That's already done. How did I know this was the exponential expression? Remember, exponential functions have variables in their exponent. So this is my exponential expression. It's already isolated, so we're going to move on to the next part, which is take the logarithm of each side. Now, I could log base 3 both sides. If I log base 3 of both sides, the advantage here is that log base 3 and the 3 cancel out, but we would be faced with change of base. If I want to get that decimal approximation, I would have to change the base here. This is a good step, but if I need to get a decimal answer, I want to try something else. Okay, so let's go back and restart this problem where we have 3 to the 2x minus 1 is equal to 5. Okay, isolate the exponential expression. That's done. Take the logarithm of each side. Now, instead of base 3, let's do ln or log, base 10. ln or log because that's what's in our calculator. I like ln, so I'm going to ln both sides. When I ln both sides, there's no canceling out. Here we can cancel because these were both 3, log base 3, exponential base 3. Here we cannot cancel log base e with the 3, so there's no canceling. But as we learned last time, we can bring down that exponent. And here is how we're going to get to solve for x. So we have 2x minus 1. That exponent gets brought down out front. Then we have the ln of 3 is equal to the ln of 5. Okay, how do I undo multiplication? We undo multiplication with division. So that would be the ln of 5 over the ln of 3. We add 1. So we have the ln of 5 over the ln of 3 plus 1. And then we divide both sides by 2, or multiply both sides by a half. That becomes the ln of 5 over 2 ln of 3, and I multiply ln of 5 over ln of 3 by 1/2. And then we have plus 1/2. This is called our exact answer. The answer is exactly this. Now, if I want an approximation to 6 decimal places, then I have to put that in our calculator. Okay, so ln of 5 divided by ln of 3 times 0.5 or times a half plus a half gives us 1.232487. And there's our approximate answer. The exact answer is the only answer that gets accepted. But if I need to know about what number this is, an approximation helps out. This number is about 1.232. But the exact answer is what we always report. Okay, isolate the exponential take a logarithm of each side, and then solve for our variable. If this were a test question, we would want to check our answer, but I'm pretty sure that we followed the steps that we needed. Okay, let's look at our next problem. Find the exact solution and use a calculator for the approximate solution to 6 decimal places. Okay, so again, we look at our exponential. Are we going to get both sides to be a base 3? Not likely. So we're going to cross that method out. We start first by isolating our exponential expression. Okay, so let's divide by 2 on both sides. If we divide by 2, we get 5 plus 3 to the x plus 1. 100 divided by 2 is going to be 50. Now we're going to subtract both sides by 5, and so that gives us 3 to the x plus 1 is equal to 45. Okay, now we need a decimal, so we're not going to log base 3 both sides. We'll ln both sides or log both sides, depending if you want to work base e or base 10. I'm going to ln both sides. Okay, ln and the 3 do not cancel out. They're not of the same base, but what we could do is bring down that exponent using our law of logarithms. Once we bring down that exponent using the third law of logarithms, we divide over that ln of 3, and finally we can subtract 1. So we have the ln of 45 over the ln of 3 minus 1. See if I can get that to write a little bit better. There we go. Okay, that's our preferred and the answer that we'll give on any test or quiz. But if I needed to know about what this number represents, we have to put it in our calculator. ln of 45 divided by the ln of 3 minus 1 gives us 2.464. We want 6 decimals, 2.464974. Exact answer versus approximation. Okay, that's the end of part 2.